Cool. So good afternoon, everyone, and thanks so much for joining us. Paola Pasalaco, I'm an associate professor in civil architecture and environmental engineering, and I'm a co-lead of a PT 2050 flagship project. So I will present with Patrick Bixler, who's the other lead of this project, and Patrick will introduce himself when I pass him the slides. So this is an update on our flagship project, which is about networks and hazards. And there's Patrick and I here presenting, but there's actually a lot of people that are putting time and effort and wonderful research into this project. And so they're all listed here. And I would give a particular shout out to all the students that you see listed here in our postdocs, as well as our collaborators in the two study areas we'll be mainly focusing on, which is the Austin area and also Southeast Texas. That is in the areas, both areas that experience a lot of flooding and definitely have a lot of needs for this type of work. So when we started, so this is actually a beautiful artistic representation of what our vision has been when we thought about this project and as we're walking through. And it's this idea of transforming the science and practice of hazard preparedness and response with a network approach. And the need for a network approach, you can actually see it very well in the drawing. And it's this idea that as we think about flooding, is not only about the river expanding into the floodplain, there's a lot of other layers that are involved into this process. And it can be flooding or it can be heat or other hazards, right? We're gonna start with flooding as a first application. And so this means that as you see on these multiplex or these multi-layer network that you see represented on the right, you're going to have the terrain information, you're going to have the rivers, you're going to have the social people, right? The interaction between people and neighborhoods. You have roads, you have urban infrastructure and so forth. And what Patrick and I and all our collaborators thought about is the fact that there's a clear gap right now. We have good solutions at each of these layers. So we're good at modeling floods, fairly good. We're good at modeling roads and things like that. But what we don't really have a lot of tools for is in really understanding how these different networks and different layers interact with each other during events, with the understanding that is this interactive system actually that needs to be resilient. And so through understanding how it works and how it responds during hazards, we can identify those critical points or weak points that will require different policies and different interventions. So we essentially have these two big goals of conducting research using these novel network-based approaches, and namely this idea of the multiplex to integrate all these layers together, and also kind of want to use this project, this opportunity to create a larger conversation about multiple hazards in Texas and also elsewhere, and integrating in this conversation the academic and non-academic stakeholders. So as we got started, kind of the story is that both Patrick and I are network people. So I'm trained as an engineer, so I'm used to think about networks as networks of water, so rivers, and Patrick is trained as a social scientist, so he's used to think about social networks. And so we got together really through a common passion for networks. And when we started looking at flooding, and that's what I've been working on for several years, what we had ready was really more methods for kind of our first step was methods for the estimation of flooding from rivers. So that's essentially what we call fluvial flooding. And that's when we start having the expansion of rivers into the floodplain. However, we know that that's not the only type of flooding that we have. So essentially, as we started working on this project, we were like, well, what about the flooding from rain? Or what about the storm surge flooding, right? Those are all things that in a city like Houston, for example, they all come in together. Or we can think about events like Harvey, when so much of the flooding was in fact direct rainfall. It wasn't necessarily the rivers expanding into the floodplain. And so we spent some time, we as the Royal We, with students that work with us, and namely Matt Pricer and Mark Wang, in developing tools that add kind of simple approach for estimating coastal flooding. So think about the storm surge, as well as pluvial flooding. So think about rainfall flooding. So now this type of information then can be integrated with other types of information, right? So as we think about these multiplex and we think about what else is happening in the city at that time, we can say, okay, what if I start overlaying this map with information, for example, on social vulnerability? So the social vulnerability component here comes from Patrick's work, and it's kind of similar to the social vulnerability used over the US, but it says more specific for Texas. So it will be looking at those specific attributes and variables that, for example, for the city of Austin matter in an event, in the case of an hazard and in general to understand vulnerability. And so the first step that we took was essentially to overlay the inundation map, which is the one that you see on the left, and the vulnerability information that you see on the right, right? So this is a static kind of overlay of the network. They're not interacting with each other, but we're putting this information together. And that way, we call this like our first approach, right? We overlay this information and we get an estimate of impact. And with impact, we're saying we're multiplying the hazard that is coming in this case from flooding with the vulnerability information. So we get a good estimation or a good map of where we look at closely, what's the type of flooding exposure that people are going to have in the different parts of town, and that combined with the vulnerability information can tell us what else we need to look at, or what are the parts of town that are in trouble, and so forth. As I said, this is kind of stage one, because when we think about networks are dynamic, so things are changing during events. But this is a static overlay. We have a map, we have the other map, we overlay with each other, we get useful information of the vulnerability of people to flooding. Now, you can take a second step, and this is what Matt is currently working on, and say, okay, what if I make this dynamic? And with that, I mean, during an event, you may be in need, for example, of evacuating, or you may be in need of reaching a certain location, for example, a supermarket, because you're out of food, or you're out of water, and so forth. So what this event is doing is to start what we want to use in the future as a dynamic approach to understand what challenges communities experience during an event, for example, like a flood. So the way this works is that we simulate the inundation event, and then we're essentially mimicking the transport of people through this network by giving them, essentially blocking some of these areas. So if we have an idea that the flooding is happening, then we can identify the roads that will be closed because of that flooding event. And thus we can say, okay, well, these people are not going to be able to access this location or that location or this location. And we call this location in blue essentially this resource parcel, which are locations that people will want to access during events. So again, this is a first cut at what the dynamics may look like, and what we are experimenting with now is to change essentially this cost function and account for the fact that, for example, when the road is accessible, you may still experience a long time to get to the resource location, or may not get there at all because there's going to be a lot of traffic and a lot of other people trying to reach the same resource location. So this is not what is currently done on the right, but it's what we're currently working right now in the project. And now I'm going to pass it to Patrick for the third stage, or third step of the project.
Yeah, thanks, Paula. So Patrick Bixler, assistant professor at the OBJ School of Public Affairs. I'm a sociologist by training and do a lot of work around the social and governance dimensions of these natural hazards. And so a big part of what my research group is doing and thinking about is how can we expand upon the social vulnerability information as important information that help people sort of prepare for, respond, adapt to these climate hazards. And so one aspect that we're really interested in is thinking about adaptive capacity, and what are those dimensions of adaptive capacity that may not be captured in a social vulnerability index. And one of those dimensions that we've been looking at is social capital. And so this is some research that we've done here in Austin, where we surveyed residents, particularly in the Dove Springs area. The sample was all of the Austin metropolitan area, but we oversampled in Dove Springs in particular. and asked about flooding. So we asked about risk perception, experience with flooding, and including mitigation behaviors or actions that folks take, both structural mitigation behaviors, but also non-structural mitigation behaviors. And what we found with this study is that there's a really strong and significant impact of social capital on people's, on actions they report to mitigate flooding. And we see this effect even when we control for social vulnerability. So to us, that sort of demonstrates that there's these dimensions of adaptive capacity that we need to figure out how to account for and potentially map that are in addition to the aspects that are looked at with the traditional social vulnerability index. Next slide, please. We're taking this work and we are expanding it across Texas. So we've been developing a new survey that we plan to launch here in the next couple of days, probably more realistic couple of weeks, but and we're gonna get a sample. We're asking a similar set of questions as we did in Austin, but we're gonna survey Dallas-Fort Worth metro area, San Antonio, Houston, Beaumont, and other residents in coastal regions. And essentially we're going to be looking at kind of different ways of measuring social capital in addition to flood risk perception, mitigation behaviors, both for flooding and for heat. And so part of what we're trying to do here is start to think about what are some of these underlying characteristics around risk perception, around mitigation behavior, around adaptive capacity that may be similar or that may be different with regards to different types of hazard types. The other thing that we're also about to do, it wasn't as immediately on my mind as this survey, but over the next month or so, we're actually going to be launching another survey that will be collecting governance network information by organizations, agencies, stakeholders in Austin and Southeast Texas. So the output of that work will be to model or network map, network diagram, and model the networks that are involved in mitigation, preparedness, response, and recovery in those two case sites. Next slide, please. Back to Paula.
Yes, back to me. Yes. So one thing that is really important is that you may think about, okay, so researching flooding has been going on for a long time, right? And so have we actually made it better? I mean, have we actually made a difference in how events locally are felt in the preparedness and the responsiveness that we have to various hazards? And so this has been something that, again, you know, the larger group of our project has been working on very much. And so we have the honor of having former firefighters that joined our research group. And that's been really helpful to really understand, okay, of all these research, of all these things, of all this network stuff, all right, what can we put on the ground now that is going to be helpful for those that have to deal with these events, right? And we saw a number of very strong flood events in Austin, right? We had 2013, we had 2015, we had Harvey in 2017, and we've been doing flooding research for decades in academia. Okay, so are we actually doing something that is helping emergency responders and communities? So Pinto Flood is specifically targeting emergency responders. This is an application that is now funded by TDEM, so the Texas Division of Emergency Management, and FEMA. And essentially this was going to be deployed in around Texas. And what this essentially allows us to do is to take the maps that I was showing you earlier, to just take the flood extent. So not the depth information right now, not the other, just the depth extent. And what you can do with this app, if you're an emergency responder, is that you can go on the ground and you're during an event and you're seeing water at a given location. And so that's going to mean that you can drop pins whenever you see water. The hardest thing as we talk to firefighters is usually to understand how bad it is, like what's the extent of the event, how much water do I have, who else is in trouble, right? You're at one location, you can't be everywhere. And so what this allows them to do is to drop the spins, and then essentially based on those, you get highlighted the likely extent of the flood based on this library of maps that we have already computed. So this is very fast, is on iPads, right? There's no calculation that needs to be done other than I have a pin, which polygon do I belong to? Let's make a delineation of where I'm likely to see water. So this is now being designed, the app itself. So there's a prototype ready, is going to be deployed in the state, and that's great. And this is just a subset, of course, of the research part that we have done. But I think what's beautiful of this project is the fact that you see the full workflow from the research side and all the network that we do all the way to something that is actually useful in the ground and will be used for years to come to improve our responsiveness and capacity of responding to these events. And so here you also see that, for example, you can also highlight which address points are going to be flooded. And again, you have an estimate of the impact of that flood event. The other thing that is happening, we just recently started an exciting collaboration with AT&T, and we got access to future flooding scenarios. Is actually going to be not only for floods, but it's going to be for other hazards as well. This is an example of a data set we just recently got access to. And so these are future climate scenarios, so following certain emission pathways, and that gets embedded into a hydrological model, which then give us access to likelihood, or like, let's say, depth of flooding to be experienced around 2050. So it's essentially a decade between 2045 and 2054. And so what we're planning on doing is also integrating these future flooding scenarios and other hazards. In fact, Patrick mentioned heat before, so we're really interested in putting all these things together. And now goes back to Patrick.
As Paula mentioned before, we're sort of starting this work with flooding, but the broader intention is to have a more integrated science and policy conversation around multi-hazards in the multi-hazard context that we live in Texas. And so part of our flagship is kind of the design and implementation of a hazard hub where folks can come together and share this information. We're thinking about this as in sort of a roundtable context. And so if we think about having these miniature roundtables on flooding, heat and air quality, drought, water supply, wildfire, having those conversations, it was helpful reminder in the previous presentation to think about the IDIRT and the work that's already happening there. How can we think about bringing together these researchers, the folks with the data, and the decision makers who have policy and action oriented needs, to have these conversations in smaller roundtables. And the next slide, please. And then to start to merge these various conversations into a more integrated and multi-hazard sort of context and roundtable and conversation. So I think we plan over the next 6 months or so to start convening some of these issue-specific roundtables leading up to a larger conversation a year from now. I think
we can both close it.
I'll say one more thing
Go
to
ahead.
close this and then pass it off to you. But just as part of that sort of roundtable conversation, we invite you all to take part, and we need collaborators. We need folks who are excited to contribute and have these conversations and really work collectively to think about the broader science and policy needs related to climate impacts and hazards.
Right. I mean, I think Patrick said it all. I would say that all the progress that we've made with, the flooding and the vulnerability analysis and what we've been able to do so far with emergency responders has really been because those people were at the table with us and, told us what was needed, told us how to do it right. And so we really value that contribution, because otherwise it would have not happened. And so this can be open, as we said, to other hazards, or how hazards come in together and compound to affect communities. And so we would like to welcome everyone to join us and continue this conversation. as we look at future scenarios and how to develop adaptation strategies in the future. So thank you very much.